Hey there, Professor Brown here, and in this video I'm going to go on a little tour through assignment 2.10, which is drawing resonance structures via pattern recognition, and kind of give you an overview and maybe a few examples of how to answer some of these questions. So the first question here says, for the compound below, locate the pattern we just learned. This one is a lone pair next to a pi bond and draw the appropriate resonance structure. So in this question, this one's really pretty kind of get right to the point. Draw a resonance structure using the lone pair next to a pi bond pattern. And to kind of help you out, keep in mind the lone pairs on these oxygens here. You can go ahead and put those in. Also keep in mind that lone pair adjacent to a pi bond is going to need to use two arrows, and when that happens, what we usually see is the pi bond moving and
ask, where do we record?
And so you should start by putting lone pairs on those oxygens, and then probably adding some arrows that will follow the lone pair adjacent to a pi bond pattern. And I'll tell you, in this particular pattern, what you'll end up with is an oxygen with a positive formal charge, an oxygen with a negative formal charge, and the pi bond that we currently see here should move to a different location in order to get the correct answer for that question. Moving on to question 2. So it says the new resonance structure is provided in the sketch box. Add the missing curved arrows on the first resonance structure to convert it to the second one. So in this case, all you have to put in is arrows. These are considered to be two resonance structures of this molecule. So you need to show an arrow that shows the movement of the electrons to get the new resonance structure, keeping in mind that the bottom of the arrow always moves from a lone pair of electrons or a bond to a bond or an atom. And that will require two arrows to get the resonance structure on this question. Here in question 3. So here we have question 3, and in question 3 it says, for the compound, locate the pattern we just learned. This again is going to be lone pair next to a pi bond. They love the lone pair next to a pi bond. So you'll go in here and click Edit Drawing. Remember the lone pairs on the oxygen. That will probably help get you started. Lone pair adjacent to a pi bond has two arrows. One of the arrows moves from a lone pair into a new pi bond, and the next arrow moves the pi bond onto an atom as a lone pair. And I'll tell you, in this question, you should end up with an oxygen with a positive formal charge and a carbon with a negative formal charge. So in this question, we have the same thing. Locate the pattern we just learned, lone pair next to a pi bond. So I will expand this one out. You should see the pi bond here in this location, and we keep in mind the lone pairs that we can't see in this case are going to be on that nitrogen. And those are the only lone pairs in the molecule, so our arrow should probably start there and go down to a bond, another bond that nitrogen has, to form a pi bond. And then to make room for that, we're going to have to move another pi bond. We know that the lone pair can't move into a bond with one of the hydrogens because that violates the octet rule for the hydrogens. So that's going to have to move it here to this bond to form a new pi bond with that carbon. To make room, you're going to have to push that pi bond up onto this carbon, and you're going to have to make sure you get your formal charges all correct for that molecule once those movements are made. Here we have question 5, and in question 5 we see all that's really happened to this molecule is the pi bond is moved from this position to this position, and the lone pair has moved from here to here, along with the formal charge on that oxygen, which particular one it's on has changed. So all you need to do is add arrows, and remember, arrows should start on a lone pair, forming a new pi bond, moving from a pi bond up onto an atom, and then getting the formal charges correct. Well, the formal charge is already correct here. It looks like all you need to do is add the arrows for this question. In this question, we again have lone pair next to a pi bond. We are asked to draw the new resonance structures in this one. So in this case, we are going to have to modify this molecule here. So we'll want to keep in mind where our lone pairs are. That negative formal charge oxygen is going to have 3 lone pairs, and one of those lone pairs is going to move to form a pi bond with the carbon that it's bonded with. To do that, that pi bond that's already there is going to have to move on to another carbon in order to make room for that. So, and once we're done, we should have a negative overall formal charge, but it won't be on that oxygen. It'll be somewhere else. So we should have an arrow here, an arrow here, and we should have the correct formal charges on those particular atoms. Here for this question, we're looking for the lone pair next to a pi bond pattern once more. So I'm going to put these lone pairs in that we want to be able to see. Nothing else should have lone pairs. The nitrogen has a positive charge, so we're not expecting any lone pairs there. If we move one of these lone pairs here using the lone pair adjacent to a pi bond pattern, then we would move one of these lone pairs into a bond somewhere we can make room with it, and we can make room by moving this pi bond here up into the oxygen. Notice this is not a good resonance structure because there's already a formal charge here, and when we do this, we'll want to be able to get the correct formal charges on this oxygen and this oxygen here. And when we make new formal charges with molecules that already have formal charges, those aren't considered great resonance structures, but this is what they asked for here, so that's what we'll give them. On question 8, we are looking for lone pair next to a pi bond, and we are asked to draw the appropriate resonance structure here. So we'll fill in the lone pairs. We're going to do all of them to talk about which ones are correct and which ones aren't. So if we fill in a lone pair there, a couple of lone pairs there, a couple of lone pairs on that oxygen, and a couple of lone pairs on that oxygen. So if we're trying to draw resonance structures, we want to be careful. We don't want to draw this arrow here, because that is 2 steps away from this lone pair, from that pi bond rather. So that is not going to be a good arrow. So the other lone pairs that we have are these here that are close to the pi bond. So I would imagine the resonance would be somewhere down here, and lone pair adjacent to a pi bond requires 2 arrows. I agree we could do lone pi bond between atoms of differing electronegativity and move this one here as one resonance structure, but they are specifically asking for lone pair next to a pi bond, so we are going to move one of these lone pairs to a new bond and then make room for that by moving the pi bond that it is adjacent to, making sure we get correct formal charges on the oxygens that have changing electronic environments. On question 9 here, they're showing us 4 different resonance actions and basically asking which one is correct. So out of the choices here, 3 of them will show an incorrect arrow notation, and 1 of them will show the correct arrow notation. This one's pretty easy to pick out if you remember that arrows cannot be shown breaking a sigma bond. In this example here on the bottom, we again keep in mind that arrows cannot break a single bond. That'll help you draw, or that'll help you eliminate 2 of them. And then for the other 2, you have to be sure that the correct atom is getting the correct formal charge to determine which is the correct resonance structure there. Here on question 10, you again are trying to find the correct arrow notation. Essentially, one of these is correct and the others are not. You need to go around and make sure, that the positive charge is on a carbon with only 3 bonds, and that the resonance arrow does not break a single bond. And in these cases, it actually doesn't. So in this question here, it's really about following the positive charge and making sure that it ends up in the correct location. And same for this example here. We are looking for the resonance, so we should see pi bond adjacent to a carbo cation, and we want to make sure that that cation is being represented in the right position as the resonance actions take place around the ring. In question 11, we have more of the same, where we are looking to make sure that the arrow notation is represented accurately, keeping in mind that arrows should start on lone pairs or bonds and end on bonds or atoms. They should not break single bonds. And it looks like in this case, really the big idea is making sure the right arrow notation is used and the correct formal charge is placed afterwards. And same thing here, making sure the correct arrow notation is used and the correct formal charge is placed afterwards. And in this example here, arrow notation and formal charge is the name of the game as well. We have lone pair adjacent to a carbocation in this case. And we should look up the correct arrow notation for that, make sure that we have the positive formal charge in the right spot once the resonance action is completed. So here on question 12, the only thing you're going to draw, once you open the drawing, notice it says draw a resonance structure. So all you're drawing here, no arrows, you're just drawing the finished resonance structure after what happens. So in this case, I will tell you it should be pi bond between atoms of differing electronegativity. So look that pattern up, figure out what would happen to that molecule under that pattern scheme, and then draw the result. It should have some atoms with some formal charges and a pi bond disappearing and a lone pair moving to an atom with higher electronegativity than the atom it's bonded to. Question 13 has the same pattern, so pi bond between atoms of differing electronegativity, and you just have to draw the result of the resonance action. So think about what the arrows would do and draw the result of you putting those arrows on that molecule to get the right answer there. Again, pi bond between atoms of differing electronegativity. Make sure you end up with a positive formal charge atom and a negative formal charge atom when you are done. Same concept applies here, pi bond between atoms of differing electronegativity. Make sure you end up with a positive atom and a negative atom with formal charges when you are done. Here in question 15, we kind of have a big intimidating molecule as far as resonance goes. You might be going, oh no, there's a whole ton of resonance here. Luckily for us, there's not. And so if we went in here and to draw, there's actually only one spot. This one again is pi bond between atoms of differing electronegativity. And there's only one instance in this entire molecule of any resonance. But this is one of the full questions, so you'll need to show the arrows and the result of those arrows. You're looking for, again, pi bond between atoms of differing electronegativity, and afterwards you'll have an atom with a positive formal charge and an atom with a positive negative formal charge, so be sure to show all of that. Same idea here. You're going to give the complete resonance action. You're going to show an arrow. and you're going to show the result of that arrow. Furthermore, this one should be pi bond between atoms of differing electronegativity, so you're showing a pi bond move from the bond position up to being on an atom, and you're showing some formal charges, a positive and a negative forms after the action is complete. So here we go in question 16. If you were quick, you might have noticed I showed the answer there quickly. But yeah, in this one we have pi bond between atoms of differing electronegativity again. And again, you need to show the full arrow and then the resulting structure. Don't forget your formal charges. That's the easiest way to mistake these. For question 17, this one's the easy one. You are going to draw the structures in the new, the arrows in the new structure. There are no formal charges in this one. This is conjugated pi bonds in an enclosed ring is the easiest one. You should draw 3 arrows, and it looks like maybe even the pi bonds are already restructured for you in this one, so pay attention to that. In question 18, we are going to use curved arrows to show the pi bond between 2 atoms of differing electronegativity. So pay attention to what they want to show. So they only want you to show pi bonds between atoms of differing electronegativity first. So you only do that first resonance structure first. Don't forget the formal charges on the resulting atoms. Then, once you've done the first one, you'll do step 2, and I'm sure step 2 will be pi bond adjacent to a carbocation. Show that resonance action and then the resulting structure second. So question 18 here is the same thing. First, add curved arrows to show using the following pattern, pi bond between atoms of differing electronegativity. So I might just do this one as an example. Put our lone pairs in for posterity, and we can put an arrow going from here, from that pi bond to the oxygen atom. And then on our new structure, our oxygen has 3 lone pairs. This is now a single bond, and we have some formal charges. We don't want the hydrogen there, so we have a negative charge on our carbon and a positive charge, negative charge on our oxygen and a positive charge on our carbon. And that should be all we have to do for that first step, because the first step is asking for pi bond between atoms of differing electronegativities. I'll click Save and Close, submit answer, make sure we're right there, and we're right there. And then step 2 opens up and it says, next, add curved arrows to show the resonance using the following pattern, an allylic carbocation. So in this case, allylic carbocation means a pi bond 1 sigma bond away from a cation, a carbocation. And in that resonance structure, we'll see the pi bond moving here instead of its current position. So we'll change the bonds around. This is now a double bond. This is now a single bond. That carbon is now neutral as far as formal charge goes, and this carbon is now our positive carbon, because it didn't gain a hydrogen, so we have to put the positive on there to show the correct number of hydrogens. So it kind of helps us answer that question. We've got our formal charges, we've got our pi bonds, we've got our arrows. We're going to hit Save and Close and Submit Answer, and that is the answer to question 18. In question 19, you're going to draw the same thing, a couple of resonance structures. You should have 2 different resonance structures for this molecule, but you'll draw the first one in part 1 and the second one in part 2. Both of these are the pi bond allylic to a carbocation resonance pattern, so lean on that resonance pattern. In fact, I think that example is pretty easy to find in a lot of places. In question 20, we have lone pair allylic to a pi bond, and I think there's only one resonance structure for this one. You're going to require 2 arrows, and the negative formal charge is going to be on the carbon rather, that ends up with the lone pair on it, so that a new pi bond should be formed. The pi bond that's there should become a lone pair on another carbon, and that carbon will have a negative formal charge when it is done. Here in question 21, we are going to add curved arrows to show the resonance using the following pattern: a pi bond between two atoms of differing electronegativity. So this is another one of the two steps. So we have, in the first step, we would show the pi bond between atoms of differing electronegativity. This is now a single bond. We have 3 electrons and a negative charge on the oxygen. That should be all we need to do for step 1. Oh, see, forgot my formal charges. We got a positive charge on that carbon now. Boom. Alright. Then save and close, submit answer. We should be right. And then the second part of the answer opens up. Notice we have lone pair adjacent to a carbocation. So that one only requires one arrow, but the positive charge should move to a new atom when that resonance structure is complete. In question 21, same thing, lone pair. This one actually says draw resonance structures for the following compounds. So there's only one here. We have lone pairs adjacent to a carbocation, and that should, in this one, you have to add the arrows and the resulting resonance structure. Make sure that positive formal charge moves to the correct atom once that one is complete. In question 23, we are going to follow stepwise through drawing all the resonance structures through this compound here, and it says first add curved arrows to show the resonance using the following pattern: pi bond between two atoms of differing electronegativity. So that probably has to do with that oxygen there and that pi bond here. And once you complete that, you'll notice a carbocation formed, which is adjacent to a pi bond here. And so that leads to the formation of a few new resonance structures that follow stepwise down through that question. For question 24, we see the same thing. The nitrogen has a lone pair. That is a carbocation in that position. So, and in this case, I actually think it looks like the structure is done for you. Well, no, you need to add an arrow, and you need to show a bond moving and a formal charge moving in the answer to that question. In this question here, we have a lone pair. Oh, so a simple one got me here. I had to think about it for a minute. Got it incorrect. I originally thought there were none, but there is. There is pi bond between atoms of differing electronegativity. Show the arrows and the resulting atoms with formal charges in the new structure. On question 26, we have lone pair adjacent to a pi bond. So this one should have two curved arrows, one starting on a lone pair and forming a new pi bond, one coming from a pi bond forming a lone pair and a new atom, and we should see some formal charges appear in this structure. And then for the final question, we are going to do the same thing. This is a two-step question. So in the first one, you've got to show a pi bond between atoms of differing electronegativity. And for this one, you'll really want to fill in the lone pairs, because remember, there are 3 lone pairs around those chlorine atoms, and those are unlike hydrogen atoms. They can accept a double bond. They don't necessarily like to, but they can accept a double bond, which becomes important in the next step of the equation. In this one, you just need to show an arrow, atoms sharing a pi bond that have differing electronegativities. Make sure you get your formal charges right over here in this structure and the number of lone pairs correct on the correct atoms in that structure. Then follow the next pattern through to answer the rest of that question, and that is all of assignment 2.10.